Welcome back. So we are going to continue on to chapter 9.3, which is addition. This chapter, I feel, is definitely going to help you mainly through example. So there's not a lot of vocab or definitions to remember. We're just going to start off with example that asks us to add. As simple as that. Now there's several different ways you can add. You can use number lines, you can pull out the fingers and count on your fingers and toes. It doesn't always work with negatives, but you could give it a shot. There's tons of different ways. I'm going to try to teach you one concrete way in which we'll eventually be able to do most of the math in our head. So our first problem we'll start with is a nice one, in which we have 3 plus -5. Now, you might already know the answer, so bear with me as I show you a way we can think of this. In our last chapter, we learned about the absolute values. Our first step here that we're going to do is take the absolute value of both objects we're adding together. So 3 and -5. And the absolute value just makes things positive. So here's our two numbers. Now, looking at the absolute values, we're going to determine which number is bigger using our order from before. So we said 5 is definitely bigger than 3. All right, good deal. So we're going to take 5 and 3, and I'm going to order them this particular way because of the signs. Since 3 is positive and 5 here is technically negative, they have different signs. And when the signs are different, I'm going to take the bigger absolute value and subtract it by the smaller absolute value. And 5 minus 3 is 2. Now this is not my answer. What I need to be careful of is who is technically bigger absolute value. 5 was the bigger absolute value. Now his sign was negative, so my final answer should be -2. Okay? So what you could do is, if you really wanted to be a little bit torturous to yourself, you could draw your number line. Let's say here is 0, 1, 2, 3. Okay, there's 3. And from 3, we are adding -5, so we're going to the left because we're getting smaller because it's a negative. So we go 1, 2, 3, 4, here's -1, and 5. Here's -2. So we plop ourselves at -2, which was the answer we got. Let's do another one, because we're going to slowly get comfortable with these guys. So for our next one, we'll call him number 2. And we will do -4 plus 9. Now, the tip-off for this method is the signs are different. One is negative and the other is positive. It doesn't matter if the first one's negative or the last one. In our previous one, we had the second guy negative, so I just swapped it around a bit now. We'll still do the same thing, and eventually we'll do these steps in our head, where we'll take the absolute value of both pieces of the puzzle and pretty much just view them as their positive format. Now determine who's bigger. 9 is bigger. So you take the bigger one, you subtract it by the smaller one, you get a result. Whatever that result is, you're going to take the sign of the bigger absolute value. Well, 9 was bigger, and his original sign was positive. So our final answer is +5. Getting a little bit used to it. So now, let's say we had a little bit different of a problem. Maybe fractions were thrown into the mix. Let's say we have -10, I don't know, 11ths plus 3 11ths. So the signs are different. And we also have fractions, so you got to remember something from way back when. It's assumed we know for this course that when we add fractions or subtract fractions, the denominators must be the same. 11 is the same as 11, so we're in the clear. If the denominators are the same, all you have to worry about is the numerators. So I'm just going to view the numerators separately right now. We can pretty much think of this as negative 10 plus 3. So we take the absolute value of both of them. We got 10 and we got 3. Bigger guy minus smaller guy. 10 minus 3 is 7. The bigger guy's absolute value, right, was 10. So we take his sign, which is negative. So our answer is negative 7 for the numerators. And whatever the denominator is, since they already were the same, stay the same. Okay. Now this is leaving up some more questions, so let's tackle a slightly different problem. Let's say the signs were the same. And I already forgot what number I was on, number 4. We have negative 3 plus negative 4. Both are negative. When they're the same, we add them together. So pretty much you can think of this as adding the absolute values and then just keeping the sign of both of them. So we really have 3 plus 4, which is 7. Now they're both negative, so our answer should be negative. Let me recap that. So when the signs were different, we did a difference, right? Oops, I can't spell because I was thinking about different. So when the signs are different, we subtract. When they are the same, we add. And we always keep the sign of the bigger absolute value. For same, when we add them, we just keep the sign of both of them. Think about it where you're in debt. I owe you $3. And then the next day I borrow $4 from you. I don't magically not owe you anything. I owe you $7 at the end of the day, and hopefully I'll pay you back. So just try to think of it that way. Let's do another one of those. Let's have it maybe where we see some decimals into action here. Let's say I have negative 4.3 plus negative 4.4. They're both negative, so they're the same sign, so we add them. When we add these two together, we're adding decimals. So the critical part is we line up the decimal point. Once the decimal points are lined up, add as usual. 3 plus 4 is 7. Decimal points line up. 4 plus 4 is 8. And we keep the sign. They were both negative, so we stay negative. Alright, so that's pretty much the rules for adding. The only thing that's going to be a little bit challenging for some of you will be adding fractions that don't have the same denominator. So, different, oh, I can't spell for the life of me. Let's say different denominators. Alright, so here's our example. We have negative 5/12 plus 1/6. Now, in order for us to add fractions, the denominators have to be the same. Currently one is 12, the other is 6. So what we have to do is find the least common denominator between the two. And we did a little bit this last chapter. So between 12 and 6, you're going to want to pick the larger number. Look at it. Okay, we got 12. Now see, if the smaller number can go into it, you already have your common denominator. So can 6 go into 12? And you're nodding your head. Yes, get to the point. You're right. Okay, calm down. So we have negative 5/12. Let's leave him alone since 12 is already our common denominator. Now, let's look at this 1/6. What times 6 gets us 12? Well, 2 does, okay? If I multiply something on the bottom, I got to do the same to the top. So what we end up with here is negative 5/12 plus 2/12. Well, negative 5 plus 2 is, well, the signs are different, so we subtract them. 5 minus 2 is 3. The bigger absolute value tend to be negative, so we have negative 3/12. Now be careful. If we can reduce the fraction, we must do so. 3 can go into itself once. We still have a negative though, right? And 3 can go into 12 4 times. So our final answer is -1 4. And that's how we add. So take care.